Hello everyone, this is Mahesh. I am an embedded system intern at Emertxe Information Technology. During my internship, I have worked on a washing machine simulation project. In this video, I will be providing you with an overview of all the topics that I have learned through this internship. And also, I take you through the project that I have worked on during my internship. Now, let's get into the presentation. Table of contents. Introduction, Embedded System, Microcontroller, Design and Board Selection, Tools used, Project Implementation, Conclusion. Introduction. A washing machine automates the process of cleaning clothes through a sequence of operations like washing, rinsing, and spinning. It operates using key components like a motor, water pump, heater, sensor, and control panel to manage the washing cycle. To ensure efficiency, safety, and programmability, a microcontroller based system is essential for real-time control of motor and valves, monitoring sensors like example door sensor, water level sensor, user interface, and cycle management. This project implements these functions using embedded C on the PIC16F877A microcontroller, demonstrating how software and hardware work together in a real-world appliance. Let's learn what is embedded system. An embedded system is a microcontroller based software hardware system designed to perform specific tasks or functions. Unlike general purpose computers, embedded systems are built to optimize performance, reliability, and resource efficiency for a particular application. Core components in embedded system: microcontroller, microprocessor, software code written in embedded C and also in C++, input devices like sensors, switches, output devices like LCD, LED, buzzer, motor, relays, power supply and timers for real-time control. For example, washing machine, micro oven, printer, automotive ECUs, industrial controllers are all embedded devices. Why embedded system in washing machine? Precision control. Timer and interrupts allow accurate control of motor and valve operation. Customization. Multiple washing programs via switch inputs and logic. Automation. Execute washing sequence without user intervention. Cost effective. Minimal hardware with reusable microcontroller logic. Safety. Monitors doors, water levels, and provide alert using buzzer. Embedded C basics. Embedded C is a set of language extension for the C programming language that supports embedded processor. It is used to write low-level hardware interfacing code for microcontrollers. Key characteristics in embedded C: efficiency, minimal resource usage, portability, runs across microcontrollers, real-time execution, works with timers, interrupts. In this project, Embedded C is used to control washing machine logic such as switching between programs, displaying status on CLCD, triggering actuators like fan and buzzer. In C, keywords are reserved words that have special meaning and cannot be used for identifiers like variables, names, or functions. In C, there are 32 keywords like auto, break, case, car, continue. Likewise, data types. Data types defines the type and size of data that can be stored in a variable. Choosing the correct type is important for memory efficiency and proper operation in embedded systems. Data types are three types. One is primary data types, derived data types, and user defined data types. In primary defined data types, void, int, character, double, float. In derived data types, array, reference, pointers, functions. User-defined data types, structure, union, enumeration. Operators. In C, operators are special symbols used to perform operations on variables and values. They are essential for creating expressions and implementing the logic in embedded system. Operators are divided into three parts. One is unary operator, binary operator, and ternary operator. Unary operator works on single operand used to incrementing and decrementing a value. And binary operator. These operates on two operands and are further divided into arithmetic operator, relational operator, logical operator, bitwise operator, and assignment operator. Arithmetic operator used for basic math operations. Relational operator used to compare values and returns true or false. Logical operator used for combining or negating conditions. Bitwise operator operates at bit level, useful in embedded system, and assignment operator used to assign values to variables. Ternary operator, it is a short form of if-else condition. Conditional statements. Conditional statements are decision-making structure in C. They check if a certain condition is true or false and then execute a block of code accordingly. Common conditional statements in C includes if else, if else if, nested if, the switch case, and the ternary operator. If if statement, it is the most basic conditional statement. The block runs only if the condition is true. And if else statement adds an else block to handle the false case. If else if used when there are multiple conditions to check one by one. Nested if. This means if is inside the if. It is used for more complex decision making. Ternary operator, a shortcut for simple else if. And switch case statement, best used when checking one variable against multiple fixed values. Each of these statements helps control the flow of logic in a program. Based on the situation, we choose the right type. For example, we use if-else for a simple decision and switch for menu-driven programs. Microcontrollers. What is a microcontroller? A microcontroller is a compact integrated circuit designed to execute specific tasks in embedded system. Unlike general purpose computers which can run multiple programs, microcontrollers are dedicated to performing one specific task repeatedly and efficiently. It combines a processor, memory, and peripherals like I/O, input outputs, timers, communications on a single chip. Key characteristics in microcontroller used in automation and control system, programmed using language like embedded C, control sensors, actuators, displays, and more. Design and board selection. PIC16F877A is a part of Microchip's mid-range 8-bit family. Is ideal for beginners due to its rich feature set and easy of use. It uses a modified Harvard architecture, means separate program and separate data memory buses, enhancing speed and efficiency. Key characteristics in this microcontroller is it is a 8-bit microcontroller from microchip technology. Operating frequency is up to 20 megahertz. Memory 14 kilobytes flash memory, 368 bytes of RAM, 256 bytes of EEPROM, double EEPROM. I/O ports. In this microcontroller, it has 33 programmable I/O pins and 5 ports, port A to port E. It has 3 timers and communication modes USART, I2C and SPI, and it has watchdog timer in-circuit serial programming. Pin diagram of PIC16F877A microcontroller. It has 40 pins. Out of 40 pins, 33 pins are I/O pins. This is the block diagram of the washing machine project. It contains 4 switches, switch 5 which is used for powering on, switch 6 which is used for pause and stopping the program, switch 4 is used for navigating, switch 1 is used for door status, and all these 4 switches are used as inputs to the microcontroller, and display is used for showing the washing status, water levels and intimation about door, and buzzer. Buzzer is used for door alarm. This motor is used to indicate that program is running. Interrupts. What is an interrupt? An interrupt is a signal that pauses normal program flow to execute urgent tasks. After the interrupt service, normal execution resumes. Why use interrupts? Interrupt response to start-stop buttons, accurate timing with timer interrupts, efficient multitasking. Example, wash, rinse, spin control. External input and timer interrupt. These two interrupts are used in this project. External input used for detecting start-stop button press, responding immediately to user input, and timer interrupt is used for managing wash cycle timing, generating accurate delay without blocking code, and it is triggered by timer 0 overflow. Timers in this microcontroller. The PIC16F877A has 3 timers, timer 0, timer 1, timer 2. Timer 0 is a 8-bit and timer 1 is 16-bit and timer 2 is 8-bit with a built-in prescaler and postscaler, each serving different timing and counting purpose. These timers can operate as timers counting internal clock pulse or counters counting external events, making them useful for delays, event counting, and PWM generation. Each timer includes prescaler options, allowing us to divide the input clock and adjust the timing interval, which is crucial for precise control in time-sensitive application. CLCD in this microcontroller. The CLCD is typically interfaced with PIC16F877A using a 4-bit or 8-bit parallel communication mode via port B or port D, enabling efficient data and command transfer. The PIC16F877A with sufficient I/O pins and stable timing control using its timer make it ideal for displaying messages, sensor values, or system status on LCD in embedded applications like washing machine interface. Tools used in this project: MPLAB X IDE. MPLAB X IDE is a free cross-platform integrated development environment for programming PIC, DSPIC, AVR, and SAM microcontrollers. It provides powerful features like code editing, debugging, simulation, and project management. all within a user-friendly interface. And Exe compiler. It is a C compiler specifically used for 8-bit PIC and AVR microcontrollers. It is optimized for high performance and supports integration with MPLAB X IDE for efficient code development and debugging. PICSimLab. PICSimLab is a graphical simulator designed for simulating PIC microcontrollers based circuit and interfacing them with real or virtual hardware. It allows user to test and debug embedded application without physical hardware, supporting integration with compiler like MPLAB XE8. Project implementation. This is how the washing machine simulator looks like in PICSimLab. Here I have selected PICGenius board in the PIC16F877A microcontroller, and this is the microcontroller, and the fan which is used to show the washing machine is running or not, and the buzzer which is used for door open feedback. If the door opens, the buzzer will gives alert. And these are the tactile switches which are used for multiple functions. This RB0 is used for switch 1, which is used for door open and close, and RB3 is switch 4, which is used to navigate the multiple programs, and also it is used to select the particular program and water level, and switch 4 5 is used for powering on and also start the program, and RB5, which is switch 6, is used to stop the program and pause the program. To power on the program, let's press switch 5. Here there are about 12 programs in this washing program, and press the switch 4 to navigate those 12 programs. First one is delay, heavy, dedicates, whites, stain wash, eco cotton, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and the loop again it will continues. To select the program, we need to press and hold for some time. Yes, here it is the water level program. Here it has total 5 functions. One is auto, low, medium, high, max, and auto, and this loop will continues again. Let's select auto, press and hold the switch for some time. Yes, here it shows press switch 5 to start and press switch 6 to stop. To first we will check if the switch 6 is working or not. So press the switch 6. Yes, it is working and the program has been closed, and again it is taken to the first screen washing program. So select the program, select the water level, and press switch 5 to start the program. Yes, it shows, as you can see, the function is wash, time is 37 and it decreasing, switch 5 to start and switch 6 is pause. So switch 6 is for pause the program. As you can see, the motor is stopped and the timer is also stopped. So press switch 5 to start the program. Yes. And to check the door feedback, press switch 1, which is RB0. As you can see, the door is open. Please close the door, feedback has been coming. So along with the buzzer, and the function is changed from wash to rinse, and again it will change to rinse to spin. Yes, after completing the program, the buzzer will come for 2 seconds. Yes, it shows the program complete, remove clothes along with buzzer for 2 seconds, and it will take you to the first screen, which is washing program. Conclusion. Through this internship, I was able to understand the importance of C programming in embedded systems, understand various types of embedded systems, and got to know where each type of embedded systems should be used. Use various tools to implement a simulation of a washing machine using microcontroller PIC16F877A. Thank you.